Wow, well that's a great introduction. Can everyone hear me? Yes. All right, so I really am fighting off a terrible cold and I am on a lot of drugs. So please don't hold anything I say against me tonight. If you do want to tweet at me, I'm H. Mason. We will have plenty of time for questions later. But if something comes to mind, I will definitely respond to it. Or if you want to email, there it is. So hello. Am I pushing the wrong way? Yes. Okay. Hi, everybody. It is amazing that this many people actually turned out to hear a talk about data. Data is not necessarily the sexiest topic. And what's also amazing is that I actually don't know that many people here. And I find that amazing because I've been running around New York yelling about data for about 3 years now, nonstop. And I've met a lot of amazing people along the way. And that's really exciting to me to see that our community just keeps growing and growing. So I hope you have had your beer, hopefully a lot of it, and your pizza. When I decided to do this meetup, I thought it would be like 20 people sitting in the Mortar Data office, and we'd just like chat about Hadoop and how much we hate it. And then the list kept growing and growing, and then Kay was like, by the way, we've got a space that holds 250 people, and it's raining, and you're all here. And so I started thinking about, okay, this had better be a decent talk because so many people are spending so much time to come and see it. And I started asking people on Twitter, people who I knew personally, what do you want to hear about? And nobody said the same thing. There were people who said, I want to know how to get started. I'm not a data scientist yet, but I want to become one. There were people who said, I'm hiring data scientists. Where do I find them? How do I evaluate them? There were people who said, tell me about hierarchical clustering. So what I decided to do for this talk is to divide it into a few different parts. And hopefully you will find all of them at least mildly entertaining, and one of them will fit each of your interests. The parts are to start with the dirty, unspoken history of data science, as I've seen it being here in New York for the last 5 years or so. The next part is to talk about how we do data science at Bitly, and I'll use a few of our projects as examples, but really to talk about the process and the engineering that goes into it. The last part is my opportunity to expound philosophically on the future of data science. And then the very last part will be open question and answers. Ask anything you want to know, and we'll see how that goes. All right. So this is one of my favorite quotes from Richard Hamming, father of information theory. The purpose of computing is insight, not numbers. And he said this in 1961. So people have been thinking about this for quite a long time. In fact, there was a movement in AI back, this is the ENIAC, 1946. Even then to say, computing is a tool for enhancing human cognitive capacity. And who deserves to have their capacity so enhanced? Like, what can we do with this? This was the point in history at which they also said they would solve the machine translation problem in 10 years. And they sort of, that didn't go so well. The field of AI was founded at this time on a conceit that all of human thinking could be reduced to rules and logic that could be processed on a machine like this, which I find to be a completely amazing idea. We've come a long way from that. So I want to tell you a little story, and it's a story about how I've seen data science actually go from being an idea to something real. So how many people here are data scientists? You would put that on your business card. Okay, what do the rest of you do? Okay, how many engineers? All right, awesome. How many business people? Okay, that probably covers everyone. If not, tell me later. So this is an extremely quite brief history of data science. Data science actually draws a lot from astrophysics and finance. And so the work that we do has been done before, and it's been done for a very long time. What's different is that now it is accessible to people without highly specialized training necessarily, and without huge budgets. So the kind of modeling that a data scientist can do is pretty much the same as what a finance or astrophysicist was doing 20 years ago. They just don't need multi-million-dollar equipment, budgets, and tools anymore, which is awesome. And there, at the same time, is this extremely powerful algorithm. It's actually a human algorithm, and it's something I've seen work a couple of times. And this algorithm is that you find something a lot of people are doing, and you name it. Now, Chris Anderson at Wired is the master of this algorithm. This is where phrases like big data, which we'll get to, come from. Data science also came from this. And it was amazing to see how there were a bunch of people who sort of latched onto it. And so when I started at Bitly 3.5 years ago, I insisted my title was scientist because I was coming from academia and I didn't want something that would ruin my CV. And our business guy at the time, he said, yeah, sure, whatever, put that on your business card. But actually, my title's still engineer in our HR system, which I found out last year when I went to buy an apartment. That data scientist didn't exist 3.5 years ago as a field of practice. It had just started to emerge at that point. And it did so in a couple of different ways. There were a core group of people on the West Coast who started promoting it, and a core group of people here in New York who started promoting it as well. And we used to have brunch and argue about should it be data science or should it be something else. In 2010, I wrote this with Chris Wiggins from Columbia University, who's also another co-founder of HackNY. And this is where the awesome comes from. We actually sat down to write down what the process of data science was, because we could not find it written down anywhere. This was in 2010. It's not that long ago. And there's the URL if you actually want to pull up our little essay where we go into each bit of this. But this seems completely obvious to those of us in this room today, right? You get some data, you clean it up, you play around with it, you build a robust model, and then you make a graph or write about it. This was not obvious in 2010, at least not to me. So we've come a long way. We've essentially invented this field at the intersection of a bunch of different things. And I've been using this slide now for 3 years, but I always tweak what it actually says. Data scientists today are a blend of mathematics, statistics, and those are not the same thing, as engineering, that is the ability to actually code the systems to do the math and statistics or to get data out of those systems, and the human interface. When I talk to CEOs, I say they can understand your business problem domain. What it actually means is that you know to ask the right questions, you can understand what people are trying to do, translate that into an analysis, and then translate it back into something they can understand. So it's the ability to write, communicate, make pretty graphs. All of these things, right? So we've had these people for a long time. But it gets better, right? So that's us. Now I want to take a step to the side and talk about big data, which is similarly something that had no name until some folks from O'Reilly sort of stamped their big data on it. Big data actually does mean something, but it's gone way too far. So this is from the Wall Street Journal this morning. Justin Lintz sent this to me because he said, big data is insane. I just did Control F to highlight big data in the article, right? It doesn't even mean anything. It says the company already uses this big data technology. Big data requires massive storage and processing power. Big data analytics across its 120 offices. It's sort of gone so far, it has lost its meaning for technical people. So when people say, what is big data? Some people think it's data too big to fit in Excel. There's another... Seriously, but there's another article going around yesterday on the top of Hacker News about the dangers of Excel, and I tweeted it also, so you should read it, about how our financial system runs on Excel. Some people think it's data too large to fit on one node, and this is the operational definition I like to use. That is, it requires specialized infrastructure in order to do an analysis on the data. That's big, right? There's another definition I like to use, which is that big data is data that can be made useful. We have always had big data. We've always had years of log files thrown on a hard drive somewhere. But it is only now that we have the tools to ask a question of that data and get the answer back before we forget why we asked that question in the first place. And that's useful data, right? There's a new definition emerging that is really dangerous, and that's that big data will tell you what to do, and you do not have to think or have a theory about your data, or in the case of medicine, it will solve all of our health problems. We don't need doctors anymore. This is bullshit. It concerns me that this is starting to pick up steam outside of the tech community, and I think we should do whatever we can to fight against it. Data will tell you whether A or B is correct, but it will not tell you what A and B should be in the first place. That's what you do. That's why we have jobs. And on that topic, what do data scientists actually do? Because it's still not clear. I think if every one of us who raised our hands when I asked if you're a data scientist actually got up and said what we spend our days doing, it would be very different. And Harlan Harris and his crew at the DC Data Science Meetup did a survey, and of course they did, they got some really great data to answer this question. And along the top are the 4 categories of data science professional, and on the side are the skills. And there's the link here as well, or if you Google Data Science DC survey, you'll get the results. It's really interesting. We spend our time doing business and strategy, answering business questions, analytics questions, doing machine learning, and what we might have thought of as big data engineering. We do math, we program, we do statistics. And you can sort of classify yourself as a data business person, a data creative, a data engineer, or a data researcher. Right? And there are lots of demands for these people. This is from Indeed Job Trends, searching for data science. I'm not sure what's going on because I haven't seen a drop in demand here in New York, but so if data scientists do so many different things, I think what all ties us together as professionals must be how we do those things and the blend of skills we bring to it. And I'd add another thing to that, which is the passion we bring to it. Data scientists tend, in my completely anecdotal experience, to be really smart, creative people who like to solve hard problems. This is from the Carnegie Mellon protest. Support vector machines, everybody. All right. Okay, then section 1 of this talk, a brief history of data science.